Hi guys, we're going to do a couple more 4.0 examples. This time we're going to involve mass. So in this problem it says determine the number of oxygen atoms in a 60-gram sample. So we're just going one beyond what we were doing before. 60-gram sample of Fe2O3, and we're looking for atoms of oxygen. Okay, so what we're going to do for this problem is we're going to identify our starting value, which is 60 grams. Okay, so we're going to go from grams, and then from grams we're going to go to moles, and then from moles we're going to go to formula units, and from formula units to atoms. So yep guys, this is a 4-step problem. That's why this is 4.0. So I've got my 60 grams. I'm going to do times in a line. If I want grams to go away, I'm going to put grams on the bottom, and if I want to get to moles, so I'm going to put moles on the top. So we're going to look up and figure out the formula mass for Fe2O3. Means we're going to need to use our periodic table. So our mass for Fe is 55.85. And in our formula there are 2 of them, so I'm going to multiply that by 2. And then my oxygen, there's 3 of them. I know that oxygen is 16, but there it is on the periodic table, 16. Okay, so we're going to put that into our calculator. So 55.85, and I'm going to do this all in one step. I think you guys can handle it since you're 4.0. 55.85 times 2 plus 16 times 3. So that gives us an overall mass of 159.70 grams per mole. So I'm going to take my number and I'm going to put it in this problem up above. So 159.70 grams. Now, the rest of this is going to be just like we did in the other 2 problems. So I'm going to do times in a line. I want moles to go away, so I'm going to put moles on the bottom. And in this step, I'm going moles to formula units. So I'm going to put formula units on top. And so 1 mole is equal to 6.02 times 10 to the 23rd formula units. And then in our final step, we're going to go formula units to atoms. So I know in 1 formula unit, so formula units is going to go on the bottom because we want it to go away. 1 formula unit of Fe2O3, and then we want to find number of oxygen atoms. So specifically we're looking for atoms of O. Okay, so I'm going to look at my formula, and it says for every formula that we have of Fe2O3, we have 3 atoms of oxygen. So we're going to put that on top. So now it's just a matter of plugging all of this into our calculator. So we're going to take 60 times 1, and then our line means divided by, and so we're going to do 159.7 times, now we have our top number, so we're going to go 6.02 second E, and that's 23 divided by 1 times 3 divided by 1 equals. And so here's our final answer. We get a whole bunch of decimals, right? That's 6.785 blah 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 blah. And our starting number had 3 numbers, so we're going to keep only the first 3 numbers here. The 5 next to the 8 tells me I need to round that up to a 9. So the 5 tells me to round up. So I'm going to put in 6.79 times 10, and then my calculator over here on the far side tells me it's times 10 to the 23rd. And that's going to be atoms of oxygen. So this is my final answer right here. Okay. All right. So let's do one last example. All right, and in this one we're just going to be going the opposite direction. It says determine the mass. So in the last one we were given the mass. This time we need to find the mass, and we're given a number of atoms. So we're going to do the exact same thing that we did in our previous problem. So the same thing we did in this problem. we're just going to go backwards. So instead of going from grams to moles to formula units to atoms, we're going to go atoms to formula units to moles to grams. Okay, 4 steps just in the opposite direction. So we're going to write down our starting value, which is 7.2 times 10 to the 23rd, and that's atoms. And this time it's of lithium, so of Li. We're going to do times in a line. And we can see in our formula there are 2 lithiums per every formula unit. So there are 2 atoms of Li for every 1 formula unit of Li2O. Okay, so the 2 again comes from that subscript right there. Now I'm going to do times in a line to go from formula units to moles. So I know that there are, so we want formula units to go away, so formula units on the bottom. We want to go to moles, so we're going to put moles on the top. And I know for every 1 mole, so for every 1 mole, we have 6.02 times 10 to the 23rd formula units. Okay, we're almost there. So now we're at moles. We need to get rid of moles and go to grams. So for every 1, so we want moles to go away, so moles will go on the bottom. We want to get to grams, so we're going to put that there. So grams and moles tell me I need to come up with a formula mass. So I'm going to go lithium equals and oxygen equals. So I know oxygen is 16, there's only 1 of them, and then we have 2 lithiums in our formula, and then I need to look up lithium. Lithium's mass is 6.94 times 2. So 6.94 times 2. Did that on my calculator. Sorry, I should have showed you. So 6.94 times 2 is 13.88. And to that, I'm going to add 16. So my total mass for all of this comes out to 29.88. And that's grams per mole, grams per 1 mole. So that means 1 mole is equal to 29.88 grams. So now we just got to put this whole thing into our calculator. And so that's 7.2 second E 23 times 1 divided by 2 times 1 divided by 6.02 second E 23, that's that one there, times 29.88 divided by 1. We're going to hit enter, and that's going to be 17.868, so on and so forth. And we can see that our starting value only had 2 numbers, so I'm only going to keep these first 2 numbers. So I'm only going to keep these first 2 numbers here. The 8 tells me I round my 7 up to an 8, so my answer is going to be 18, right? So it's going to be 18. I don't have any times 10 to the anything, so it's going to be 18 grams of Li2O is my final answer.